All right, hey guys, we're going to do a tutorial on U-substitution because as much as you're not going to have a multiple choice question on it because you won't have multiple choice, you will definitely have that concept, I have no doubt, in your AP exam, even on your free response questions. So what I did was I kind of split screen number 1 and number 2. Hopefully you see that number 1 on the left is not U-substitution. And basically, look at the difference between these two. Here, this is just a plain old regular 5x plus 4 being integrated. But here we have 5x plus 4, but it's raised to the 5th power. So that's where we're going to have a U substitution. Can you see the difference there? Okay, this is just a regular 5x plus 4. And this is a 5x plus 4 to the 5th power. So like for me to double distribute this thing out 5 times and then integrate it is a pain in the neck, and that's why they do the U substitution. All right, so then if we look over here on the left, the 5x plus 4, well, that's going to become 5x squared over 2, right, plus 4x plus c. And that would be our answer for the left-hand side. Now on the right-hand side, because we have a quantity here that's being raised to the 5th power, that's when we want to do U substitution. So figure out what your U is going to be. Okay, so then our U, I'm going to just stick it down here. U is going to be 5x plus 4. I don't know why my pen's not working here. And so then that would mean that our du would be the derivative of that, which is 5 dx. All right, so then remember what you want to do is we start by looking at the du. And we see that it says 5 dx. Well, right here all I have is dx, which means I'm going to need to multiply by a 5 inside here. And then remember, on the outside, we're going to put the reciprocal of that. So I'm going to stick a 5 in here. I know this is going to be messy, sorry. And a 1/5 out there. So what that's going to give us is 1/5 the integral of u to the 5th du. Okay, good so far? All right, now we're just going to integrate this. So let's bring down that 1/5. And we're just going to integrate u to the 5th like it was an x. Okay, so that would be 1/6 u to the 6th plus c. Do you see that? Okay, so we are just treating this as if it was an x to the 5th. That would become x to the 6th, right? Divided by 6. Thus, where that 1/6 is coming from. All right, now we don't have bounds here. So remember, with U substitution, when you don't have bounds, you're going to take this value, u, and we're going to substitute its value back in here. That's when you don't have bounds. Okay, so I'm going to make this, let me just make sure, yes, I am in black. So we're going to do 1/30, because that 1/5 times that 1/6. All right, now let's substitute our u back in, which would be 5x plus 4 to the 6th power plus c. And that would be your answer. All righty? All right, let's try another one. So I'm going to do one more split screen so you can kind of see the difference between these two. This is just a regular radical x, but this has more junk underneath the radical than this guy does. Okay, and that's why over here I do not need to do U substitution, but over here I'm going to want to do U substitution. All right, so let's first change this around a little bit to make it look a little bit nicer. So we're going to make this the integral of x to the 1/2 power. Okay, so now remember, when we integrate, we're adding. So that would be x to the 3/2 power, right? Which means then I need a 2/3 in front plus c. and that would be your answer. Okay, now over here on the right, let's do the same thing. Let's just start by making this 4x minus 2 to the 1/2 power. Okay, and now, because you have an expression here being raised to the 1/2 power, as opposed to just one variable raised to the 1/2 power, that's when we're going to have to do U substitution. Okay, so let's figure out what that U is going to be. And I'm going to just stick it up here off to the side. So U is going to be 4x minus 2, right? 4x minus 2, which means then our du is going to be the derivative of that, which is 4 dx. Okay, so now let's look, remember when we're doing this, we start by looking at our du, which is 4 dx. Well, I have a dx here, so obviously what am I missing here that I need to multiply by? And then remember, we need to multiply by its reciprocal outside. Okay, so I need a 4 in here, and I need a 1/4 there. So that's going to give me 1/4. I'm not going to integrate yet. I'm just going to rewrite it. U to the 1/2 power du. Okay, now I want to show you. See, what we have here is very similar to what I have here. The only difference is that I don't have a number out here. And this is going to be a u, in which eventually we're going to substitute its value back in. All right, but let's just kind of go along. So I'm going to just bring that 1/4 down for right now. And I'm going to integrate u to the 1/2. So that's u to the 3/2, right? Which means I need 2/3 here. And then plus c. Okay, now you know that I like to get those fractions on the outside. So when I'm multiplying these two fractions here, I'm going to get 2 over 12, which is 1/6. So I'm just going to bring that 1/6 outside like that. And my u to the 3/2, let me substitute that u back in. So that's going to be 4x minus 2 to the 3/2 power plus c. Okay, and there you go. All right, now looking at this next one, I would hope that you would see that we're doing U substitution. So there's two things that you want to look at when you're trying to figure out your U. You kind of have two parts to this problem. We've got the denominator that's got the radical, and then we kind of have this numerator, so to speak, because this dt, we could write it right here. So you have something underneath the radical and something not. Now remember I told you that there were a couple things that you should look at when you're trying to figure out your U. Usually your U will be the thing that has the higher power, which would be this. The other thing your U would most likely be is something in parentheses. And even though we don't have parentheses here, we do have a radical. Now, not always, hear me out, not always, but a lot of times what's under the radical will be the U, but not always. So don't always assume that. But in this case, it's also the higher power, so I'm going with that. So then that means that I know that my U is going to be, what is going on with my pen? U equals t cubed plus 4, right? So t cubed plus 4. Now du, let's take the derivative of that, and that's going to be 3t squared dt. Okay, so go over here, and let's look. This is my U, and this essentially is my du. So what do I need on the inside? And then what do I need to multiply by on the outside? All right, so on the inside, I need a 3, right? And on the outside, I need a 1/3. Okay, so let's just rewrite that before we do any integration. So that would be 1/3, the integral. Now, let's look at this numerator here. This is really my U. I'm sorry, my du. Sorry, du. See how this matches that? Okay, so then in the numerator, we're going to write du. And then if you look in the denominator, this is my u, but it's underneath the radical. Okay, so then I'm just going to change that just a little bit, and that's going to be u to the 1/2. Okay, all right, now I don't really love that either, so I'm going to go one extra step. And what do you think I should make that to make it easier for us to integrate anyway? I would make that u to the -1/2 du. Okay, so then let's integrate. So let's bring down that 1/3, and here we go. Well, u to the -1/2, if I integrate that, that becomes u to the what power? To the +1/2, right? Because we're adding 1. And then if I have a 1/2 power, what number should I put right here in front? Okay, and hopefully you're saying 2. And then we have plus c. Okay, so now I am just going to multiply these two guys here and bring them out. So that's going to be 2/3, right? Okay, I'm going to substitute the u back in because I don't have bounds. So that's going to be t cubed plus 4. Oh my goodness, I do not know what's going on with my pen, so sorry. That's supposed to be a plus sign. And then what are we, to the 1/2 power? Plus c. Now, guys, on your AP, they don't care if you simplify. So you can leave it like that. If you prefer your other option, and you don't have to do this, but you could write it as a radical if you want. Okay, that would be also fine, but you don't have to go that far. All right, so number 6, let's look at that one. Remember what I said on the last problem. I said, what do you usually pick as your u? Okay, so when we're doing this, what do you think your u is going to be? And my thought would be, let's make our u be sine. And the reason being is because it has the higher power. This doesn't have a power. Okay, so we always like to try, it not always work, it doesn't always work, but if we can, let's pick the higher power. Now, what's the derivative of sine? Cosine, right? Okay, so before I start doing any integration, I'm just going to rewrite this. So I have the integral of u to the 10th, and then let's just look real quick. Do you see what I have here is exactly my du. So I don't need to multiply by anything. I'm just going to simply write du like that. Okay, so that's like integrating x to the 10th. All right, so what do we end up doing? Or what do we end up getting? We should get 1/11 u to the 11th plus c. Now we don't have bounds. So remember, if you don't have bounds, you're just going to plug that u back in. So sine x to the 11th plus c. And there's your answer. Now, if you want to write it like this, I'm just going to show you. Both of these are acceptable. I don't really care how you write it. You can write it with the 11 at the end, but if you're going to write it, let me point to it. If you're going to write with the 11 at the end, the sine x has to be in parentheses. Okay? If you want to write it here, that is equivalent to this. But again, you need these parentheses. All right, now I'm going to warn you, this one's a tricky one, and I gave it to you on purpose. It is a little tricky. But I want you to look at the fact that we have a radical, but we also have a radical here. Okay? This radical has a little bit more attached to it, and it has a power. So my thought is, what do you think? Maybe, take a guess. What do you think your u should be? Okay, so I am hoping that you are saying that your u should be radical x minus 1. Now, you may be like, well, I don't understand. Hold your horses. Now, remember radical x minus 1, let me rewrite that, is going to be really x to the 1/2 minus 1, right? Okay, so then let's look at our du. So then our du would be 1/2 x to the -1/2 And that minus 1's derivative is just 0, right? All right, well, let me rewrite this du. Maybe this will help. Isn't that 1 over 2 radical x? Okay, so I want to just take a minute and let's just talk about this for a second. So I'm going to go back to the very beginning. When you're deciding between this and this as your u, this has more junk with it. That usually means, not always, but that usually means that that would be your u. Also, this expression has a power of 2, where this is really, just like a power, well, if I was putting it in parentheses, it's power of 1. So that's kind of why I went with this. Rearranged it, took its derivative. Now, the reason why I rearranged this and wrote it like this is I want you to see something. And actually, I just realized that I did not write dx here. Okay, so let's look at this. Isn't this, look at what we have right here. This dx matches that dx. This radical x matches that radical x. So the only thing I'm missing right here is a 2. So if you look at it then, do you see what I need here is a 2, and then all of this is my du. Okay, but just be careful. Putting a 2 down here, listen to what I'm saying. If I put a 2 down here, what am I really multiplying this entire expression by to get this 2? I'm going to repeat it one more time. What am I multiplying this entire expression by to get this 2 down here? And I hope that you're saying 1/2. So if I have a 1/2 on the inside, then I need a 2 on the outside. So just be careful. And the reason why I'm multiplying by 1/2 is because this 2 is in the denominator. So technically I have a 1 up here, the 2 down here, there's my 1/2, which means then I need a 2 on the outside. Okay? All right, so then let's rewrite this. So then I have 2 on the outside, the integral of, all right, so let's look at what we have here. This is my u squared, right? Okay, so then I'm going to write u squared. And then this whole mess right here is my times du. So I'm going to write du. All right, so let's go ahead and integrate that. So, well, u squared, if I integrate that, is 1/3 u cubed plus c. I'm going to multiply that 2 and that 1/3, so that's 2/3. And then u cubed, right? Now, u cubed, remember, I have no bounds here, so I'm plugging my u back in. So then that is going to give me radical x minus 1, that's my u, cubed, plus c. And there's your answer. Alrighty, well here come the bounds. So let's just start it off the same way we've been doing all the other ones though, 1 through 7. So the first thing we're going to do is come up with our u, right? Alright, so why don't you take a minute, you can pause me and tell me what you got for your u and your du. Alright, so for my u, I would have x squared plus 2x plus 2, because that's the thing that's in parentheses and it has a higher power than the numerator, which is just an x plus 1. All right, du then would be 2x plus 2 dx. All right, so just a quick. So then if I have 2x plus 2 dx, but here I only have x plus 1 dx, do you see if I multiply this x by a 2, I'll get 2x. And if I multiply this 1 by a 2, I'll get that 2. So then I need to multiply the inside by 2, and what do I need to multiply the outside by? Right? So this is going to get a 2, and then the outside's going to get a 1/2. Okay? All right, now, what is the other difference when we're doing U-substitution and we have bounds? Do you remember? Remember, you have to change those bounds. How do we change those bounds? We take each of the bounds and what do we do with them? we substitute them in to the u. Okay, you like the yellow, isn't that cool? I like that. Okay, so then anyway, I am going to change those bounds. So when I put in, hold on a second here, why do I have -1 to -1? All right, hold on, I did not mean this at all. Do you see if I have a -1 here and I have a -1 here, wouldn't the integral just be 0, right? When the bounds are the same? Ooh, 2 lessons in 1. When the bounds are identical, remember that means that the answer is going to be 0. That's not what I meant to happen here. So my assumption is that this top bound was supposed to be a +1. I don't know why I have a -1. So let's go with that. All right. So if I put in a +1 in here, I get 1 squared plus 2 times 1, which is 2. So that's 1 plus 2, which is 3, plus 2, which is 5. Oops. Put my pen on. That might be helpful, right? Okay, 5. And then let's do the same thing. We're going to put -1 in here. So -1 squared is 1. That would be -2. So 1 minus 2 is -1. And -1 plus 2, right? -1 plus 2 is 1. Oh, and again, I don't have my pen on. There we go. All right, so then what we have here is du over u cubed. Okay, now I don't love that because I don't like that u cubed being in the denominator. So I'm just going to rewrite this integral from 1 to 5. And that's going to be u to the -3 power du. Okay, so let's just go ahead and integrate. So that's going to make that u to the -2 power over -2, right? Okay, we are going to end up evaluating that from 1 to 5. And then that whole thing is being multiplied by 1/2, right? Okay, now I know that maybe that's a little bit ugly, but we can fix that. All right, so how do we want to fix this? I think I'm going to start just by getting rid of this -2 and bringing it out here. So do you see that if I bring this -2 out there, that's going to make that -1/4. Are you okay with that? Remember, I like to bring the constants out. So that's going to give me -1/4. Okay, whoops. -1/4. There we go. Okay, now the next thing is I see that I have u to the -2. I'm going to make that a positive power. So how would I do that? What would be in here? Do you see that that would be 1 over u squared? Okay, and then we evaluate from 1 to 5. Now let's talk about that. So if you have a definite integral, you do not need to substitute your u value back in here. So when we look at this u value, that never ever comes back in here, because by changing these bounds to 1 and 5, we've now kind of, in a sense, gotten rid of this and replaced it with this u to the 3rd in the denominator. Okay, so there's no need for us to go back and replace a u value in. So once we change these bounds, we can just leave it simplified like that. It's just easier. Okay, so then what this gives us, oops, let me put my pen back. So I have -1/4, right? So then what I have is 1 over 5 squared, right? Because it's top bound, minus bottom bound, 1 squared. And then I'm just going to work that out. So that's going to give me -1/4, and that's going to give me 1 over 25 minus 1. Okay, now on your AP, you can leave your answer like this. You don't have to, but you can. So if I were you, I'd leave it and just be done. I'm annoying, so I'm going to keep going, but you can totally be done here. So I'm just going to distribute this through. So that's going to be -1 over, what is that, 100? I don't know why my pen's giving me trouble. And then that would be plus, and that would be 1/4. And I'd quit while I was ahead. So either this answer is fine, or this answer is fine. You can go ahead and you can make a common denominator, but it's totally not necessary. All right, so I think the $1,000,000 question here is what do you want to choose for your U? What do you think the best thing to choose would be? I'm going with sine x. Why? Because it's underneath the radical, so stuff's being done to it. Isn't that very mathematical sounding? But that's what I would do. Okay, so then obviously your derivative of sine would be cosine. And I'm squeezing in a dx down there. Okay, so let's look and see if we need anything. So remember, if we need anything, we're going to find it right here in our du. So this says cosine x dx. Well, look, I have cosine x dx. So I don't need a thing, right? Okay, now what's the next thing, though, that I need to be careful of? What do I have to do? Because I've used substitution, but what do I have? I have bounds, right? So where are these bounds going? They're going into U. And we're going to change those, right? All right. So if I put pi into sine of x, what is the sine of pi? Oh boy. Sine of pi would be 0. Okay. Next thing is I'm going to put in 0 in here as well. And what is the sine of 0? And I'm hoping that you are saying 0. And, oh, yay, I said this on the last one. What ends up happening? Do we even need to go any further? No, we do not. Because as soon as you have, now, by the way, these numbers just happen to be zeros, but if I had a 5 here and a 5 here, or a -2 and a -2, it wouldn't matter. Okay, because you have the same bounds, top and bottom, your answer is 0, and we're done. Okay, now, never mind. We're just going to leave it. Alrighty, last one. So, here we go again. What do you think your U is going to be? Okay, so I'm going to say my U is going to be x cubed plus 1 for 2 reasons. The main reason really is when I take the derivative of this, it'll be something with an x squared, and that's what I have here. The other reason is because that's the thing that's underneath the radical, which is kind of like a parentheses, if you will. So that would be another reason why I would choose that as my U. Okay, so that's going to give me 3x squared dx when I take the derivative, right? Okay, and then now let's look, because we have to determine whether we need to multiply by anything, right? And the way we do that is by looking at our du. Our du is 3x squared dx. So I see an x squared, I see a dx. So what do I need on the inside? And then what do I need on the outside? Okay, so on the inside we need a 3. So the outside, we need a 1/3, right? All right. The next thing that we need to do, though, is what? Because it's U-substitution with bounds. Where do these guys go? They go into our U, okay? All right. So let's rewrite this a little bit. So I'm going to have 1/3. The integral. Now my top bound right now is a 1 right here. So let's take that 1 and put it in here. And what do I end up getting? 2, right? Okay, now if I take my bottom bound, which currently is a -1, let's put -1 in here. What do I end up getting? 0. Okay, so then let's rewrite what I have underneath here. So then I have, let's just look at this. This is my U to the 1/2 power, and then 3x squared, and my dx is my du. Okay, so I'm going to write that. So I'm going to write U to the 1/2 power du. Okay, so let's integrate. So I'm going to keep that 1/3. When I integrate U to the 1/2, that's going to become U to the 3/2, right? Which means I need a 2/3 in front, which means I'm sticking that on the outside like that, and then my bounds from 0 to 2. No plus C because we have bounds. All right, we also remember that because we have bounds, we do not need to replace this u with our x cubed plus 1. That's not necessary. Okay, all right, so I'm going to multiply those fractions on the outside. So that's going to give me 2/9. And let's see what I have here. So I have 2 to the 3/2 power minus 0 to the 3/2 power. Well, 0 to the 3/2 power we know is just 0, right? Okay, and let's just talk about this for a second. This is technically the square root of 2, which by the way we don't know unless we had a calculator, and then cubed. Okay, and now I'm just going to show you, you do not need to do this. And I honestly would suggest that you don't, but just to show you, this would be the square root of 2 and then cubed. Okay, if I were you, I wouldn't even bother with that. I would just say 2/9 times 2 to the 3/2 power. On your AP, you're not going to have to simplify anything. Call it a day. All right, so I hope this little tutorial in U-Substitution helped. If you have any questions, please shoot me an email. And if there's any topics you want me to go over, just shoot me an email. All right, take it easy, guys.